Hello everyone and welcome to the fifth and final webinar as part of our September webinar series. I'm joined this afternoon by Pini and he is going to be talking to you about testing cloud native applications. If you have any questions for Pini, please type them into your questions field and we will get to them at the end of the webinar. And don't forget, you can type your questions at any point during the course of this webinar. So now let me hand you over to today's presenter, Pini Resnick. Hello, Pini.
Hello. Yes. Good afternoon, everyone. Thank you for joining this webinar. And I'm going to talk about testing cloud-native applications based on our experience. I'm in Container Solutions, located in Amsterdam, and we are consulting around cloud-native applications, microservices, and similar technologies. So let's start. Before I go into specific experiences we had over the last couple of years, I'll talk a bit about the theoretical background, so we will be on the same page about the cloud-native microservices and other technologies. So possibly you see this diagram in different shapes and different ways, shown by Docker presentations or other technologies or representatives of other companies. Basically, 20 years ago we had monolithic applications with physical hardware. This is a fairly common story, but I'm still going to tell you because it will give us the introduction to the topic itself. So basically, a few years ago we had this new type of architecture of kind of thin mobile client that replaced or started replacing monolithic applications, and this kind of honeycomb of dependent components like web servers, databases, some third-party libraries, and they were already running mainly on the cloud, on virtual machines. And at that point we probably had in typical medium-sized companies, we had dozens or even hundreds of machines, physical or virtual. And today we're seeing transition into microservices, and they're typically called microservices, but there are other names for that. And the idea behind is that everything becomes even smaller. So we are not talking about full virtual machines, but really, really small pieces talking to each other, services that can be built by a single two-pizza team or whatever else definition is out there on the internet. And of course, we are mostly running on clouds. It doesn't matter if those are public or private clouds. And there is a rise of containers that really help to take the microservices further on and enjoy the benefits of basically reducing the complexity of monolithic large applications that are almost impossible to build in teams, in large teams. Of course, it will continue and things will become even smaller. We don't know yet how. There are some hints like unikernels or other things. But the direction is very clear. Everything becomes more complex, but bigger become every piece, then more need we have to divide it into smaller pieces, both on application side for services and infrastructure. So we're moving from physical machines to virtual machines, and now containers, and in future possibly unikernels, even smaller pieces. So we like to see it as a transition that is kind of similar to nature, like biological structure. So there was like single cell systems and then multi-cell systems and kind of organs and complex organisms. So then what is cloud native? It's not very well defined at this point. There are some attempts to define it better, But the main idea behind is that cloud native application is an application that built with running on the cloud in mind in the first place, not adapted to or not put on the cloud forcefully, like in virtual machine, and somehow make it work there, but built in the first place to run on the cloud. And the first example, probably first famous example of this, is 12-factor app from Heroku. And of course, microservices are aiming to, microservice architecture is aiming to solve this same problem. Create an architecture where you can build your applications that will run same way on local environment as on the cloud, or you will not really see the difference. So Linux Foundation has a collaborative project called Cloud Native Compute Foundation, and it's a open source initiative that is aiming to promote and define these concepts better. At this point, CNCF Charter says that the goal of Cloud Native Compute Foundation is to foster innovation in container packaged, dynamically scheduled, and microservices-based applications, and scaling to tens of thousands of self-healing multi-tenant nodes. So essentially, we are talking about microservices mainly, with containers, with modern technologies, with scaling, migrating from cloud to cloud, and fairly independent from operations. This doesn't take away the continuous delivery pipelines. Actually, it forces us to use them even more. So there is no easy way to build 50 microservices without full automation of continuous delivery pipeline, or some kind of flowing system of delivering value to the cloud in a quick and stable way. So this is an example of a diagram we were using for our clients, and we see more and more demand from companies to essentially it's very difficult to build microservices and avoid continuous delivery in some way. And that brings us, of course, to DevOps. This is the common definition of DevOps. There is when we want to take a value from business through development to operations, we need to, or typically before, 5 years, 10 years ago, developers would define the application, package it, and then kind of throw it over the wall to operations. And in many cases, it failed during the deployment because production environment was different from development environment. So DevOps movement is addressing this by basically encouraging developers to learn more about infrastructure, and operations engineers more learn how to build software. So essentially, we put them all together, and they together solve the problems, and they make sure that the software we are building is both high quality on the code level, but also can fit the infrastructure and continuously built, tested, and delivered through multiple stages. They're very similar to each other and consistent. We think that this movement of DevOps is very popular, and it will be even more important to make it fully automated. So we see that the responsibilities between operations and developers kind of shifting. So there are more and more developers who understand infrastructure, and actually every developer working on microservices needs to understand infrastructure to a certain extent and understand how the services are running on the cloud, how they're operating, how the networking between them is working. Everything is essentially the infrastructure becomes part of the application itself, in the same way as build processes and testing became part of the application itself. On the other hand, pure operations engineers, they move aside to actually maintain the cloud itself. So they are also essentially developers, but they are creating create and maintain the cloud with clear APIs so developers can deploy their application all the way fully automatically without involvement of any manual work throughout the pipeline. So essentially, manual testing is more or less impossible in this environment, because even if it only takes an hour, it breaks the flow of the changes. So we as a company, we don't have any testers, and we don't recommend our clients to have a separate testing teams. So all this said, I want to talk about a couple of projects we were involved in, and based on those explain how we think testing might be done. Of course, this is not a full comprehensive guide of testing for microservices. Those are our kind of report on our experience and some recommendations based on actual projects. So the first project we started about a year and a half ago, and it was actually two projects, one called Monto and another Shipped, both built by Cisco, and we've been part of this team. Essentially, Monto is a cloud management software. So it can manage one or more public or private clouds. It's based on the core part of Monto is Mesos, but it includes dozen or 2 dozens of different tools inside to create one comprehensive solution, kind of one cloud with a clear API that developers can use. And Shipped, on the other hand, is a delivery platform. It can receive microservices definition from a developer and take them through continuous delivery pipeline all the way to Monto. So, of course, this whole project is about microservices. It's about taking microservices and delivering to the cloud. This is one of the clouds and one of the delivery pipelines. But the challenges are very similar to similar projects. So the first project we were doing was ElasticSearch framework for Mesos. And I'm not sure if everyone knows about Mesos, but in very few words, Mesos is a scheduler, distributed scheduler for mixed loads. So basically, you can have Mesos master, central management system, and multiple slaves, and then kind of applications that called Mesos frameworks that are running on top of Mesos, and they will share the resources of the entire cluster. Essentially, Mesos combines, or in this case, 4 slaves into one big machine, virtual, or not virtual machine is the wrong word, but essentially the users of Mesos system see all the hardware behind the Mesos cluster as one single machine with a lot of resources. So ElasticSearch is, of course, also a distributed system of multiple agents combining into a cluster of Elasticsearch. So essentially we have some hardware, typically on the cloud. Then we have a distributed scheduler, Mesos, and on top of that, another distributed system, ElasticSearch. And this kind of projects, building this kind of projects is fairly difficult. So our experience was that it is difficult, and we need kind of a set of tools or SDK to help us to address certain challenges. This is not, I'm not going to talk about each one of them, but this is the recommendations, or these are the kind of missing pieces that we identify that would meet or would need to be solved before Mesos framework development becomes easy. And I think it's fairly easy to see that a lot of this is about testing. So basically, when we move from testing single monolithic application that is running on single machine to testing microservices, there is totally new set of challenges related to distributed system. So when you start Elasticsearch cluster, and if I go back for a moment, Mesos framework has a scheduler that is running on the master and executors that are running on different slaves. And they all perform together in some asynchronous way. So basically they talk to each other in some way, and it makes it very, very difficult to create test procedures or consistent test procedures to make sure that your software is working. So so the biggest challenges we found was how we debug, trace, test, make sure that those applications, those frameworks, and make sure that they are high quality and perform as they're supposed to. So the biggest problem we had was that actually deploying Mesos was very difficult. So from our previous experience of doing configuration management, we knew that the most important thing to solve was creation of local development environment. Essentially, if you cannot recreate development environment on your own machine, or it doesn't have to be your own machine, but your own private development environment on your machine or on the cloud or in some place that only you work with, and if you destroy, no one else is affected, then it really creates problems in the project between the developers. So we built the system called Mini Mesos, which is basically it's a full Mesos running in multiple Docker containers on a single machine. We can start it in a few seconds, and it creates fully functional Mesos where we can deploy our frameworks. And Mini Mesos is integrated with testing frameworks. So in this case, we can start Mesos cluster in a single function, and then do some JUnit integration and run some tests, basically to treat our distributed application like it is kind of monolithic, because it is all basically we are starting distributed system on a local machine, and then treat it as kind of single thing. So Mini Mesos also has a configuration file, integrations with all kinds of things, with Maven, with continuous integration tools, and this really allows us to develop microservices or distributed applications in using same tools as we used to use for monoliths. So the next step was to build additional Mesos frameworks, Logstash and Kibana. In this case, it really becomes very, very complex system. It doesn't really matter what this diagram shows. It's not the point of this presentation, but ensuring that 3 different distributed systems running on top of Mesos, which is another distributed system, is a really significant challenge, and it requires different tool set for testing. We actually use the ELK stack to collect information about running systems. So Logstash was installed everywhere and collecting data into ElasticSearch and then shown in the Kibana. And basically our work was to build this ELK stack on top of Mesos. So the next project we built was again to improve the quality of the distributed applications, and essentially we know that failure is inevitable. It's going to happen if we want it or not, and based on the concept of Netflix Chaos Monkey, we create Mesos Monkey, which is just running all the time and killing things essentially, which is helps us to deal with problems that we know will happen in real life. So from our experience, this really changes the mindset. When you have Mesos Monkey or when you have Chaos Monkey running in your system, then you kind of embrace the failure and you live with it, and you make it part of your development process. And it means that you are not delaying the solutions related to random failures because you hope they will never happen, but you're dealing with them and improving them because they're happening all the time. So the functionality of Chaos Monkey, essentially it kills things. So the next big project we've been doing was microservices demo. It was a demo application for socks shop. So essentially it's kind of a pets shop from 10 years ago when people were learning how to build websites. So together with a company called Weaveworks that is building networking and visualization tools for containers, we built this demo to show how would you build microservices applications. So essentially it's a very simple web application, and it's built based on about 10 different services. And this is a rough architecture of this application. And of course this is overcomplicated for a simple web application, but it's intentional because the goal is to actually demonstrate the architecture. And we're using different languages like Node.js, Go, Java, and we're using all kind of different databases and different services, and they're all collaborating and talking to each other. So essentially this replicates an average microservices application. So this is more or less amount of containers running in a real system. This is a visualization tool that shows real containers of running with SOX application. So during development of this application, we had certain levels of testing: unit testing, component, container, taste testing, which is a bit different than normal, API integration, and some advanced testing techniques. Not all of them are implemented, but I'll go one by one and more or less explain what we are trying to achieve in each one of them. So first, unit tests, and there is nothing new there. It's at the end, it's just testing the code within the component, and yeah, you still have components. They are smaller, and they're more independent. So unit tests are very important. And of course, like in any other system, we encourage to use more and more unit tests because they're cheap and very quick. But there is nothing new in unit test area for microservices. On the component test level, we essentially create bigger components or services in this case, and then simulate dependency using fixtures and data fixtures, and then basically test them without testing the dependencies. Again, there is not much new in this area. This is still fairly low level. Here, some differences starting to appear on the container test. Actually, before microservice or before containers were used, therefore there are no container tests. But the idea is to create, essentially every service becomes one or more container images, Docker images. And what we are doing is injecting mock dependencies and then testing or running different scenarios for behavioral testing. So this is the binary artifact is different. It is a container. It is different from, for example, jar, but it's essentially same concept. So we create final artifact. We inject or we mock dependencies, and then we run higher level tests that more behavior oriented or functionality oriented, and not low level unit tests. And I think the most important, and probably the part that is different from analytic, is API testing, and this is absolutely essential. So what we do is, first, it is very, very important in microservices architecture to define APIs very, very well, because when you have a dozen or 50 or 100 microservices, they all have different delivery cycles. They are delivered in different times by different teams. And the most important thing in microservices is to make sure that you have very well-defined contracts between service producers and service consumers. And the reason for this is that when you redeploy one of the services, either producer or consumer, they can trust the API and they will not fail. So you may still have a bug within one of them, but at least it will not create chain reaction and destroy the entire system. So we are using Swagger to define the APIs, and later use a system called Dread to basically create, simulate consumers of APIs and ensure that they are performing as agreed based on the contract. On the integration level, we think it's very important to have private development environment, private testing environments. Essentially, every developer or everyone can create an environment on a local machine or in the cloud, deploy the entire application with all the dependencies or some of the dependencies, and see what's happening. For example, if you want to check a new version of Java, you need to be able to do it without affecting work of anyone else. The next step would be to create collaborative test environments. So the first part we are addressing with Mini Mesos for Mesos, and there is also Minikube for Kubernetes, and there are Docker Compose for Docker. So essentially everyone can create complex environments on a single machine and deploy the application and test them. The next step would be to create collaborative environments where multiple teams or multiple developers can combine their systems into one, test them, see if it's working, and then move on with the development. So this is very important for the development time. When two teams need to create something that basically something together in collaboration. Of course, there are advanced tests. In our example of WebSock's application, we don't have any of those. But the next steps are stress and performance testing, and this is very important for distributed applications because the amount of services is significant. It's very difficult to actually know what's going on with each one of them, and their behavior changing very, very quickly. So when, for example, it's a web application and the load on the front end is growing, we have no idea how it will affect backend systems or all kind of other systems that indirectly related to the front end. It means that all the pieces in the infrastructure need to be able to scale and respond to new demand and to changes in the environment. We think Chaos Monkey is essential for distributed systems because those failures will happen, and they happen more frequently than when you're running on a single machine. And there are all kinds of things like network disconnects, or there are so many components involved in running microservices that something is always wrong. And Monkey actually makes those things very explicit. We think there is a lot that can be done on the level of during the development, like tracing and debugging, but also later logging and monitoring of distributed systems. A lot of work is done around monitoring containers, but there is still a lot of work to do. We have a series of articles about this, and this is a huge topic. And essentially, monitoring and logging distributed systems is very, very different, especially because the pieces of the application, the microservices, they are so small and they are changing so quickly that traditional monitoring and logging systems are not capable of delivering same level of response. And of course, the next step would be to do A/B testing and blue-green deployments. Again, when you have 50 different services and you tested them in all kind of testing environments, still you want to make sure that they don't break something and be able in best possible situation to deploy a small piece of application, make sure that the entire system is performing, and if something happens, if the system is affected, even if you're not sure if the deployed component was the reason for that, you just automatically remove it and roll back to the previous version. Because the first priority is survival of the system, and second priority is delivery of new features. And that was blue-green deployments, but A/B testing is of course also when you want to decide if A version of the feature or B version of the feature performing better or delivering better results. You can deploy both for different subsets of users and see which subset basically creates higher revenue or higher value for the client. So to summarize or basically emphasize the two most important parts of testing distributed applications or cloud native applications is those 2 points. One, having consistent, reliable, and quick local and private development and testing environment is very, very important. It saves a lot of time. It dramatically affects the quality of the development. When the teams are working on centralized environments and are capable of reproducing them on local machines or in some kind of private way, then the speed of development is way slower. So I think this is one of the most important parts, and this is not just important for microservices, but once you have many moving pieces and you can only reproduce 2 of them, it becomes very difficult to test complex scenarios and dependencies between different parts of your system. And another very specific thing for microservices is testing of the APIs, ensuring that the contract between producer and consumer of the APIs is consistent and provides exactly the results that the other side expects is absolutely essential for microservices. This is probably the biggest problem when one of the services asking for data from another service and receives something that it cannot understand, cannot read. That's why we are spending quite a lot of efforts to ensure those APIs and then test that they didn't change. And of course, in the future, with current project, we don't have versioning for APIs, but of course, when we build proper microservice applications, every change in API should result in new version of that API. And that is more or less covering what I was planning to say, and I would be glad to hear any questions.
Thank you very much, Pini, for your presentation. I'm just going to go through one or two other slides here before we have a look at the questions. And if you have any questions for Pini and you haven't already typed them, please do so now. So this time next week is the deadline for our early bird discount, where you can save up to 10% on your conference ticket. So to avail of this discount, head over to the EuroSTAR website and you'll see links there to bring you through to our pricing page, where you can view all the different ticket options. Another option that you might like to avail of is our group discount. And here, if you buy 4 tickets, you will get a 5th ticket absolutely free. So that's 5 tickets for the price of 4. So now let's take a look at some of your questions that have come in. The first question I have here for you, Pini, asks, what tool do you use to test cloud native applications?
Yeah, so yeah, unfortunately, it doesn't really work like that. It's a combination of many tools. So because microservices are everyone is different. So for example, in our demo application, we have every service is written in different language. So the unit tests are appropriate for those languages. And then the mini Mesos system is integrated with JUnit. So we can run normal JUnit tests on complex environments. So there is no some kind of magic tool that just answers this question. It very much depends on the specific environment and specific setup. Yeah, not a very good answer, but also when we deploy and define microservices, there's also a question: what kind of tool would you use to deploy microservices? And of course I can say something like Mesos or Kubernetes, but it doesn't really answer the question. There are many more tools involved. So at this point, there are no comprehensive platforms to address this stuff, these questions. It's a combination of small tools all together creating a reasonable environment. So yeah, I'm not aware of a tool that can solve this problem.
Another question here asks, is Mesos different from Docker Swarm?
Of course it is, but it is built for the same purpose, essentially. They are both schedulers. Mesos can schedule containers or normal tasks, not containerized tasks. Swarm is only scheduling Docker containers, but essentially both are responsible on creating a single pool of resources based on many physical virtual machines and giving away those resources to applications. So that's basically the goal of the scheduler. In this sense, Swarm and Mesos and Kubernetes and HashiCorp, Nomad and other tools, they are competitors, and each one is doing this task in a bit different way.
How can we test security of the data on cloud-based applications? Is the data secure in the cloud?
Those are very good questions. The answer is that data is secure in the cloud or unsecure or not secure in the cloud, depending on your actions. So if I use an analogy, if you have a house and dozen locks, but the back door is always open, then is it secure or not? So we have examples of, or I heard about examples of companies with very expensive and powerful firewalls configured in a way that allow everyone to get into the system. So having tools doesn't mean security. Being on the cloud or off the cloud doesn't mean security or the opposite of security. What it means is that, so basically if you do everything right, then cloud can be as secure as private environment or even more secure, because the companies building clouds like Amazon or Microsoft or Google, they are experts in this, and they really help you to make sure that your data and your applications are more secure than average, let's say, because otherwise everyone will suffer. Their image will suffer, and potentially through your applications maybe some damage can happen to them too. But if you are working in your own data center, you're still exposed to the internet. You're still exposed to hackers and attacks, and operating systems and all kind of packages that are not patched and potentially can lead with to very bad results. So the answer is if you know what you're doing, then the data on the cloud can be fairly or even very secure. If you don't know, then yeah, then you are in trouble.
Okay, I don't see any other new questions just there at the moment. If you have any questions, please type them in. While you're here as well now, I'll let you know as well that you can avail of all of the webinars during this week on the Test Huddle website. We've recorded them all, and their slides are there as well if you want to recap on any of the sessions you may have missed or any of the ones that you want to have a second look at. And also over the last week, we've released a number of ebooks that I believe you would be interested in. There's an ebook on Selenium testing called the Selenium Guidebook. We have another ebook on better test design, and the third ebook that we've released during the week as well is on how to remain relevant and employable, Tester Edition by Rob Lambert. Okay, I don't seem to see any more questions coming in there, Pini, so I think we might just wrap it up at that. And I'd like to thank you for taking time out and presenting today's webinar, and to all of our attendees for coming along to today's webinar as well as the other webinars throughout the week. That draws our September webinar series to a close, and we hope to see you all at future webinars over on Test Huddle. So thank you all and take care.
Thank you.